Welcome everyone to episode 5 of our Inspire webinar series. My name is Albert Dryfout. I'm Head of Training and Operations at Inspire Africa, and this afternoon we are venturing into the world of 3D design and printing. Our specific topic for this afternoon is Fusion 360 for 3D design and printing, and we'll basically look at 3 different topics. We'll start off with a basic introduction to Fusion 360. Just indicating a very simple exercise on how we could use Fusion 360 to create something very straightforward. I'll do a quick comparison with Tinkercad. Many of you might be familiar with Tinkercad. Then I'll move over to how a school can get free access for Fusion 360, as Fusion 360 is free to educational institutions, but there's a little bit of a process attached to that, so I just want to run through that. Then lastly, Greta will take us through a little bit of curriculum integration on how we would then actually use this in the in our day-to-day curriculum. We'll end off with a quick Q&A session. Hopefully there's time, but in the meantime, anyone who have questions, please raise your hand, pop the questions into the chats. We'll try and answer them as much as we can. So I'll start off by just quickly sharing my screen. And you should be able to see it now.
Yes, we can. Thank you, Albert.
Okay, so what we see in front of us is Tinkercad. Most of you would have worked with Tinkercad. Very easy, very simple design software. So in here we see something that I just put iTrain on it. Essentially, it's a little train with a few gears on it. And if you turn the handle on the gears, the wheels turn together on both sides, essentially. Now, when we work in something like Tinkercad, we would typically make use of existing 3D shapes, and we would change the way they look by making use of various parameters that we can play around with, or we'd make use of the various libraries, let's say shape generator. There's quite a few different handy things in there. For some reason, mine's loading quite slow, but you'll see there's gears and springs and all kinds of things in there. But typically, what you would do then is you would make use of an existing object, modify it to suit your needs. When we start looking at something like Fusion 360, it works on a completely different principle. What we see in front of us is a simple pulley, basically. I'll show you in a moment how one can fairly easily create something like this in Fusion 360. But before we start off with this, let me just point out a few things. So firstly, when we work in Fusion 360, we always start off with a 2D drawing. So if we want to draw literally anything, we would have to select our drawing plane. In this case, I would just use the XY plane, and we would then make use of, let's say, a simple square. And first we would draw that square in a 2D dimension. So if I rotate this now, we would see that it's only a 2D square, and it has, there's no resemblance of a 3D object. And then from there, we would then usually either extrude or rotate that object to change it into a 3D object, like the little block that I have created now. Now, that means that students need to understand the relationship between 2D and 3D sketches. That's why it's usually better to start off with something like Tinkercad, because straight away students work with 3D objects. While the moment we go into Tinkercad, you need to understand the different faces of objects and so forth to find the easiest way to draw an object. Now, looking at something like a pulley, there's quite a few different ways that we could do this. Now, to illustrate that, I'm going to take this existing one and just cut a quick cross section through it. No, not on that face. Just select the right face. There we go. For some reason, no, it doesn't want to. Okay. I'm just trying to see. Okay, for some reason, no luck now. But basically, what we're seeing when we're looking at an object like this, if I would take away the handle, for instance, then we would see this object has many axes of symmetry. So if we were to cut this specific shape in half, which was exactly what I attempted now, and for some reason it would not do that. Let me just give it one more go. So I'd really like to indicate it to you. I don't know what's going on there now. But in any case, so if we do cut it in the middle, we would see from this side that we literally have actually a rectangle with a little bit of a half curve on the one side, which is the part of the pulley where the rope or the belt would run. So we're going to make use of that idea to create our specific object. So if I remove this one and there, then we would start off first by creating a very simple sketch. So in the top right, top left, we have a create sketch button. We will share this recording afterwards, so you don't need to keep up 100%. But I would like to draw on the XZ surface, and you'll understand in a moment why. What I'm going to start off with is a little bit of just a very simple square. Okay, so we have our square. You can see that it's just in 2 dimensions, and essentially what I want to do is, if I were to take this and I would revolve it almost. So if we were to look at it from the top and I would revolve that shape in a 360 manner, I would end up with a disc and a little bit of a hole in the middle of the disc. Reason for that hole is if I rotate around the y-axis, we see we have a little bit of a space there, which will then result in a little bit of a hole in our disc. So let me first adapt my sketch a little bit, because we do want to create a pulley. So what we're going to do is we're just going to grab the circle and we're going to draw a little bit of a circle in there. There we go. And we must always remember to finish our sketches before we can turn them into a 3D shape. Now, let me indicate to you what the idea is now. You'll see straight away as I select the surface, because it's split up into various different surfaces, by just selecting that part and literally just clicking on it. I mean, I can select any part of my surface, but now all of a sudden the circle itself is left out. So if I now select my rotate tool, I need to select 2 things. Firstly, the profile, which is already selected, and then I need to select the axis around which I would like to rotate this. In this case, that is now the Z axis. The moment I click on it, it says automatically it rotates it around the angle of 360, which then allows me to have a complete new shape. And you can actually see what happened with my 2D shape when I then rotated it to create it into a circle. Now, this is probably the easiest way to create a quick pulley if you wanted to, let's say, 3D print a pulley and so forth. Very easily now we could add a little bit of a handle on it. Again, we would click on the sketch as I just did. We select the surface that we want to draw on. In this case, on top of our pulley, I'd grab another circle and create a little bit of a circle there, finish my sketch, and in this case I would then extrude it, not rotate it, because the idea is just to make it an elongated shape. And there I end up with a pulley and a little bit of a handle. Now, it might seem a little bit daunting if you've never worked in Fusion 360, but once you've played around with it a little bit, everything kind of falls into place. Now, one could very easily now in Fusion 360 go and automate this specific pulley. That's the advantage of something like Fusion 360. Let me just create a little block for myself. I just need a new sketch. I'm just going to draw this on the surface. And go a little bit faster because we are slightly running out of time. So I'm just going to create a little block. Then I'm going to extrude this block to make a, let's call it, just like almost like a block where I can attach my pulley onto. And that is the case as it is there now. And I'll need a little bit of an axle for my pulley to run on. So again, I would add another sketch. I would draw on top of my block, bring in a little bit of a circle. Needs to be exactly how big that previous one was. I didn't take note of that now. Let's assume it's somewhere, oops, somewhere there. And again, I need to extrude that little part to create a little bit of an axle for my pulley. And all I need to do now is I'm just going to tell the software that it is a joint. Before I can do that, I need to make sure that these things that I created here are currently called bodies, and they need to be converted into components, meaning components of a working system. So I just select them here on my left-hand side in my working pane, and I say create components from bodies. Then it automatically does that for me. Now I can just join them. So I would take the center of my pulley, I join it to the object that I have there. Maybe I would like to move it down a little bit. I think my axle is a little bit too small potentially. And yeah, now I moved it in the wrong direction. Let me just Control Z and undo. Just quickly join it again. So I'd like to join that part with that part over here. See if I got the right part in here now. Sorry, let me just make sure that I'm completely out of that tool. Join that piece onto this piece. There we go. And I'm just going to rotate it before I drop it down so I don't move it in the wrong direction. And I basically slide it over my little axle. And now I can just tell the software that this specific component that I've got here, meaning the square block, is the one that is fixed. So I'm going to right click on it and just say ground so that we know it's fixed. And I'm going to make sure that my joint is actually a movable joint. Currently is set as rigid. I'm just going to say revolute, meaning to move around it. So now I can basically move it around my basic system that I've created. So very straightforward pulley. Obviously one can create multiple pulleys in here now, and then also then attach them by making use of belts. And for those of you that are interested in that, I'm more than happy to make a little bit of a video just to show you how to get something like that done. Now typically what I have shown now, we would teach to the students not in one shot. We would start teaching them about just what a pulley does, fixed objects, moving objects, and then teaching them about extrusions, revolutions, and so forth. But at the same time, we need to make sure that what they are actually doing is something that is worthwhile to them, keeps them interesting. So the final would be to print a little system like this and actually show them that what they've designed on the computer really does work in real life. Which brings me to the second part, which is essentially how one would get access to something like Fusion 360. Because usually Fusion 360 is quite an expensive piece of software, but it is available for educational purposes. So I'll quickly put this link into the chat that I've opened here. A few important things to note when you work with that link. That link is specifically a US link, meaning that this is organized from the United States, not from Fusion 360 or Autodesk in South Africa. When you go into this link for the first time, it's going to ask you, do you want to change to the South African site? And you want to say no. Because the moment you change to the South African site, you'll see that we're going to lose that whole link to get educational access. So very important not to do that. Stay on the US site. There's quite a nice video that basically takes you through the whole process. What it comes down to is that students need to send a letter to Fusion 360, same for you as an educator, proving that they are a student in that specific school, and the same for you as educator. So very simple standard letter. I have a little sample here, which I'm also willing to share afterwards, which basically just from the student side is a confirmation that the student is in fact in that specific school. So obviously you would need your name as educator, your position, school name, contact information. Actually, before the student sent this one with their details, you as educator would first send again a letter to them following the procedure as is explained in the video on that link that I've provided. And important to note in there, obviously, your name, your position at the school, the grades that you teach, and then that letter needs to be signed by the headmaster or the headmistress to basically give it, let's call it authenticity.
Albert, I'd just like to jump in there. Another request from Autodesk, from Fusion 360, is that these letters are on an official school header. Right, yes. So you can use your school header or place your school emblem, something that authenticates your request and links you to a school. Majority, and I've checked, majority of the schools on the Fusion 360 website, as you go through the registration process, is listed. Now, regardless of where you come from in South Africa, you should be able to find your school. If you don't, you can email them directly and explain the process, or explain your your situation. Thank you.
Thank you, Greta. Yes, yeah, that's good just to mention that, which basically brings my part to an end. So you could have kept talking, Greta. Greta's now going to quickly take us through a little bit of the curriculum that we use from Inspire Africa's side when it comes to 3D printing. Over to you, Greta. I assume that you would like to share your screen.
Yes, please. Hi, everybody. I'm Greta Robinson. I'm the curriculum manager at Inspire Africa. And I work together with amazing educators who help me create content for our schools, for our teachers, for our students. And we don't just focus on 3D printing, we focus on a range of other 4IR products, such as microbit robots, internet and e-communication forming part of our coding and robotics curriculum. And we have a curriculum from grade 3 right through to matric. So I'm just going to demonstrate our 3D modeling curriculum to you now. So I want to share my screen. Sorry, I glitched there.
While you're sharing, just so that everybody understand, we don't work with textbooks. All our lesson plans and worksheets are available via the Inspire Campus, and they are completely downloadable. Students also get access to the Inspire Campus to be able to access the content and so forth.
Right. Albert, am I sharing?
You are, yes.
Okay. Right, great. So as Albert mentioned, our educators and students can access the Inspire Campus. Everything is online. We have curriculum for foundation phase, intermediate phase, and senior phase is where I'm going to focus on for our 3D modeling curriculum. So if you click into your senior phase, you will see a variety of different categories that we have, from coding and robotics curriculum, a full year's curriculum from grade 7 through to grade 9, robotics, and then our 3D printing and CAD. Just to mention, we also have drone coding courses. We've got Python text-based coding where they learn to code games, some real-life PBL missions, and subject-specific lesson plans. In terms of our 3D printing and CAD, we have got a variety of different courses, moving from course 1 or course 2. Your students can start in a specific course, such as course 1, and then move on to course 2 and course 3. You can integrate these courses into technology or into your coding and robotics curriculum or as an extramural program at your school. We have created lesson plans that align similarly to technology, where they are creating pulleys, they are creating gears and cars, and they're really using design work to model their designs and following a step-by-step instruction as provided from our LMS. The idea behind our curriculum is that your educators do not have to be pros in 3D modeling. We provide a step-by-step instruction. Here in the first course, it just starts with 3 lessons of Tinkercad, and then we move into Fusion 360. So if I just click onto Fusion 360, for every lesson, your students or your educator gets a lesson plan, which they can store and file. Some schools are wanting to assess this. Some schools only require it as evidence of learning. Others just use it as a reference, where your educator can get the lesson plan and the notes. And then there is a brief for the learners. This is a nice piece of information or resource that you can provide your learners to have something to store into their portfolio and to build up evidence of learning from your students, from the student's perspective. Just going back quickly into our lessons. So your student would typically click onto the first lesson, whereby there are instructions for you and for your students. You can choose how you would like to present this to your students. It can either be by projecting on the board or having your students go through the curriculum themselves. And then they would just go through and then just navigate onto the next page. Throughout this navigation process, there are pictures, there are step-by-step instructions, there are video tutorials for you and your students to work through. Right, so I'm not going to go through everything, but that is the basic layout of our lesson plans. Our courses are typically created for a term's worth of work. So you could do all of the courses within 3 terms, or you could say your grade 7 start with course 1, grade 8s with course 2, grade 9s with course 3, or start your grade 8s on course 1, depending on if they have any other prior experience. And then lastly, just for those of you who are interested as well in 3D modeling, our intermediate phase also has 3D modeling and design content for you, starting with basic modeling, basic shape drawing in Tinkercad, moving through another course where they can eventually start to pick and choose items that they would like to create, a coffee mug, a raft. This is really ideal if you'd like to bring this into your arts lesson and have your art teacher do a 3D modeling and design lesson with their students. All right, I think that is all I have to show at this point. If there are any questions, please, let me know.
Thank you, Greta. Yes, I don't know. I see there's a question from Ronnie. Are we able to integrate your lesson plans into Google Classroom and assign the lessons? Ronnie, maybe I can answer that for you, Summer. So, yes, what you could do is, because the courses, the worksheets and such is essentially PDFs that one can download, that is possible. But the clickable content sits inside our LMS, which is a Moodle-based platform. So unfortunately, the downloadable content, of course, one can share through Google Classroom, but some of the other content that sits inside it that's not downloadable one won't be able to move that over.
Yeah, I think what they could do though is, if you have got a specific lesson in mind, you could click on the link of that lesson, and once the learner is logged in, that would direct them directly to that specific lesson. So let's say you do want to do a gear design, you can then just copy the link to that lesson and then pop it into a space where your learners can then click onto that link and takes them directly to that lesson. So that, but the actual content, like Albert says, cannot be moved across, only the PDF resources.
And there's no other questions at this stage. Greta, maybe I have a quick question. Let's say I'm at a school where I don't have a 3D printer. would it still be worthwhile venturing into 3D design?
Absolutely. Remember, it's the 3D model and design skills that the students are learning. So for them just to play around, to tinker, to problem solve will be of enormous value for your skill, for skills development for learners as young as 10 years old, all the way up to matric, even through EGD. If you're bringing 3D modeling into engineering, graphic and design, you could have them tinker and play around, knowing the basic skills. Then later on, if you are privileged enough to have a 3D printer, to print it, to see and to view the end product. But our course focuses on that skills development. We do not just provide you with a template to print to say that you are 3D printing. That is not what 3D printing and design and modeling is all about. It is actually building up the skills in order to do that in real life. I heard somebody saying, I don't know if it was you, Albert, who mentioned that 3D printers could possibly become the next microwave, where everybody in every household might have a 3D printer one day. And just the design, the learn, the skills necessary, and where we are moving towards in our ever-changing, technological landscape, this provides students with a great skill, not only for that, but also towards subject choices when they enter into grade 10 and choosing and just being exposed to those different skills to choose to have career opportunities and choices of careers.
Awesome. Thank you, Greta. Yeah, I think maybe to continue on that, the prices of 3D printers have come down immensely. And initially it was, a 3D printer was like a thing, calibration and those kind of things were quite a process to go through. But a lot of 3D printers now are actually very easy to use. They come with auto calibration, those kind of things. So the landscape's definitely changing and the prices are coming down. So in reality, some certain 3D printers that cost, let's say, over 10,000 2 years ago, you can buy them now for about 3.5. I'm not saying you want to buy those because those are the older technology ones. You might want to spend a little bit more just to get something that's a little bit easier to use. But yeah, it definitely shows a trend that it's becoming more inexpensive. Same thing with filament. I've had many people in the past ask me, is it, in terms of now you need to buy these rolls of filament. How many rolls of filament do I need? Now, typically the schools that do make use of our programs would go through a maximum of 6 rolls in a year, where that is basically a kilogram roll, and they're not that expensive. A kilogram roll of filament, you're looking at about 350 to 450 rand, depending a little bit on the filament type, color, and those kind of things. But it's really not big money as it used to be. I don't know if there are any other questions, comments, even maybe some educators would like to share if they have been working with 3D printing. All very quiet. All right. In that case, thank you for joining. It was a nice, quick one. That's the idea of these sessions, to make them quick, powerful. Yeah, Greta, I don't know if there's something that you would like to mention still.
No, just a huge thank you for those of you who are attending and listening to the recordings. Always lovely to see continuous faces coming and supporting our webinars. I would love to hear from any of you who are in the EGD, engineering, graphic and design field, and you are using Fusion 360 or any other 3D modeling platform. Please reach out, get in touch with me. Love to collaborate.
Definitely. Thank you, Greta, and thank you everyone also from my side. And please keep in mind that Inspire Africa is here to support you. So if you have any further queries related to this topic or require further assistance with the implementation of 4AR technologies and curriculum in your classroom, please do not hesitate to reach out to any of us at any time. And we're wishing all of you a wonderful afternoon further ahead. Until next time, take care.
Thank you. Bye-bye.